Okay, so something else that's kind of new here, not only are the translations in words, or the whole concept of translations is new, something else that's new is what's referred to as a mapping notation. Again, okay, you're going to see a mapping notation in pretty much every unit in all of the pre-calculus and the calculus course. Okay, so we're going to get things started here. Okay, mapping notation is not necessarily the equation of the function, but it definitely describes what's happening. So what we do is we write every mapping notation is going to take this form right here, where we say xy is mapped onto, and then notice here, okay, what's going to happen is we have something after the x. Any number that shows up after the x is the horizontal translation. X is horizontal, left or right. So if it's a positive, it's going to move to the right. If it's negative, it's going to move to the left. So you can see here that the x plus 1, that represents a horizontal translation of 1 unit to the right. And then the number that comes after the y in the mapping notation is your vertical translation. And of course, vertical is up or down. If it is a positive, it's up. If it's a negative, it's down. So left is negative, to the right is positive, up is positive, and down is negative for the y. So what we're going to do right now, it's going to seem a little bit dry right now, okay, but we want to make sure that we get practice going from an equation to a mapping notation and describing those translations in words. So what I have here is we're no longer dealing with parabolas in general. What we're dealing with is just other types of functions. This can apply to any type of graph. Doesn't matter what it is, but notice here that we usually refer to our original function as f, and our new translated function is usually referred to as g, and g is some version of f. So you notice that in each of these two examples that I have here, okay, the g of x function is the f of x function with some other things added to it. So we're taking the f of x function and we're moving it around. So let's take a look at doing a mapping notation for this equation right here. So first of all, every mapping is going to look something like this. It's always going to have an x and y here, but what are we going to put after the x and after the y? Well, notice that if the equation says x plus 2, then in the mapping notation we do x minus 2. And that is our horizontal translation. And then notice the number at the very end, the minus 4, we do not change that. So we keep it as a minus 4 in the mapping notation, and that is the vertical translation. So many emails. All right, so anyway, now that we have our mapping notation identified here, let's take a look at doing a description in words. So we would say right here, we would state our horizontal translation and our vertical translation, and we have to have a number and a direction. So the horizontal translation, it says minus 2, so that is 2 units to the left. So as long as you have the number and the direction, then you've done a description in words. And now we have vertical translation, which is minus 4. Vertical is up or down. If it is minus, then it is down. So we're going to move 4 units down. Now I don't have an actual graph here, but whatever the original graph is, we take that and move it to the left 2 and then down 4. In this second example, what I want you to do is I want you to smash that pause button, try this one on your own, and then play the video again and see if you got the correct answer. All right, so now that you tried the answer, let me correct this for you. First of all, okay, our mapping notation for this would be x plus 3 and y minus 5. We change the sign of what comes after the x in the equation, and we know that gives us our horizontal and vertical translation. And what we can do right here to do the description is we can say the horizontal translation is 3 units right, and the vertical translation in this case is minus 5, so that would be 5 units down.